Okay, greetings everyone. Happy Monday. Welcome into my channel. I am Professor L, and this is a live stream for math tutoring. So if you happen by chance to be out in YouTube land and you are tuning in and you need help with your math, perhaps I could help. You're welcome to um, leave in the comments, the chat. You can post a math problem and I will see it, and I will do my best to work it out. In the meantime, this is me hanging out on my board, just playing with some math and practicing working and presenting upper level math topics. So right now with this platform, I have been doing some graphing. And so, almost 2 months now I've been doing this, and I've sketched a different graph almost every day. So it'd be kind of weird if I didn't. But so, yeah, today I am going to be furthering kind of the discussion of transforming graphs, but I'm going to be working with a different function. And so just kind of backtracking from last week, I graphed a couple of systems involving, one of them involved a hyperbola and the other one involved an ellipse. So I worked on some definitions over the weekends, writing out all of those definitions for hyperbolas. And so I really want to practice. I looked at the graph of a hyperbola that was centered at the origin. So tonight, I haven't graphed one of these in a while, so this will be interesting and a little exciting for me. What I want to do is I want to graph one that's not centered at the origin. So, yeah, just kind of reflecting back on my previous presentation, because part of this is me learning and trying to fine tune my method and make sure that I'm giving the most detailed math that I can, and when I'm presenting it, the most concise. What I realized is I didn't reduce my fractions, and I know that 26 doesn't divide 4, but I could have divided a 2 out of both the numerator and denominator. That would have been 13 halves. So it's always best practices to work in reduced form. However, sometimes I get a little bit lazy. All right, where is my eraser? All right, so everything else looked pretty clean. We just were shifting the graph of the square function around, and looking at the basic transformations. So moving forward, we can see how the different equations in the graph are manipulated. And really my goal is to make it back to the trigonometry. And I really want to get back to sketching some of the graphs of the trig functions, and their transformations. So the transform graph of the trig functions. Okay. Anyway, it's always hard coming back from weekend because I don't present math on the weekend. So trying to get back to explaining the math. So I need to go ahead and remove the heading, because what we're going to do is we're going to be looking at the equation of a hyperbola. And the hyperbola is, it's one of the conic sections, and it's the one conic section that actually has a mirror image. It has a reflection where it produces the graph of two objects. And those, I learned that those objects are called branches. And it produces two branches. And it says that it's is the result of a conic section that has been intersected by a plane. So it's a double conic section that has been intersected by a plane. And we're not going to put all of those, we're not going to put all those definitions up here, because what's the point? We have Google. But what I'm going to do is I'm going to use those definitions to sketch. I can't call this a function because it's not one. It doesn't pass the vertical or horizontal line test. But it does lead to hyperbolic functions. So if you take pieces of the hyperbola, then you can produce functions. So we'll see that when we look at a graph. Okay. All right, where is this function at? Did I not write it down? All right. X plus 2 quantity squared minus, I wanted to get one in general form. Y minus 4 quantity squared. Oh, minus 4. Okay, x plus 2 quantity squared over 9 minus y minus 4 quantity squared over 16 equals 1. 9 and 16 equal 1. So this is called standard form. And so what I need to do is I need to go ahead and get this out. This has got all of my values on it. And I think I can go ahead and write the formula by memory, but all of these other formulas, which there are a lot of them, I need to go ahead and get help with. So we're going to go ahead and pull out the form. It's x minus h quantity squared over a squared minus y minus k quantity squared. Wait, it's plus. I think we'll look. B squared equals 1, and I'll have to double check. Perfect. Oh, it's minus. Okay, what do I do? Switch it. Okay, it's okay. So here is the form that we're going to pull our values from, so it's important. So this is the form. And the center is at h comma k. So here, let's make a list. So we've got center is at h comma k. So that equals, all right, so your form is negative, your value is positive. That's going to lead to a negative k value, because two negatives make a positive. So you kind of have to think backwards. So there's your H, and then your K is negative. So your value is positive. So here's your center at -2,4. There's this thing called a directrix. Directrix. Okay. And it's found by the formula. All right, so what we have to do is we have to determine whether our hyperbola is horizontal or vertical. And if it's in this form, it's a horizontal orientation. So there's two different forms depending on if it's horizontal or vertical. And so this one is the horizontal. So we're going to go ahead and switch this title, I guess. Horizontal hyperbola. And then maybe tomorrow, I mean, very squeaky marker, but we're just going to roll with it. All right. So let's see. Directrix is, so what basically I understand about a directrix is that it's a vertical line in your graph that is, if the value is used in calculating the eccentricity, which is a constant that it appears throughout your, it's a constant that is involved in defining your conic section. All right, so x equals plus or minus a squared over c, and then it says c is found by taking, it's using the distance formula, so it's the square root of a squared plus b squared. Okay. Then you have, should we put the rest of these up here? That was the hardest one. The other one is the asymptotes. So we'll put that up here. Asymptotes. And there are two asymptotes that form a perpendicular intersection at the center, I discovered, with these hyperbolas. So we have a perfect diagonal through the center of the hyperbola, and it has a slope. So it's for horizontal hyperbolas, it's y equals plus or minus b over a. Over a times x. Okay, so there's your asymptotes. And then there are foci or focus is the plural of them, and there's two of them, and they are at, for height, horizontal, it's plus or minus c, comma 0. So we'll go ahead and put those in here, focus. Order pair, it's plus or minus c, comma 0 for horizontal, and then it's reversed for vertical. And then the other value that we have to find is the vertex, and the vertex is at plus or minus a, comma 0. Or a, hang on. It's not going to be a, comma 0. Hang on. It's going to be a, I believe it's going to be a, comma k. So k, we'll put k question mark, and then when we look at the graph, we'll determine that. because I wasn't thinking about that. The vertex, that's if the center is at 0, 0. So A, maybe, I don't know. I've only graphed one of these, and that was this weekend. It was I went ahead and sketched the graph of one that was centered at the origin so that I could be able to sketch one that's not centered at the origin. So what the A value is doing is affecting, it looks like the domain of the function, and the B value is tied to the range. And so with these equations of these funky graphs, it looks like the A would be affecting the domain, so then we would have to move the range, manipulate the range. So I'm thinking that this is going to be K. Some K value, not 0. All right, and then there is another value called the transverse axis. And I don't really think that we need that for this sketching. So let's go ahead and get out our handy dandy Cartesian coordinate system. And see how we do. I think we're going to need both the X, all 4 quadrants. So we'll just make it as big as possible here. Let's see here. What do I want to start with? I want to start with the center. So what we'll do is we'll say 1 and then 2. So I want to first calculate the center, or locate the center, and then calculate the asymptotes. And go ahead and sketch them in here as a dotted line. Okay. So our center is not at the origin. It is at -2, 4. So we've got -2, +4. So there's the point that we're going to start our asymptotes. And we've got b minus, or so plus or minus b divided by a times x for the equation of the line for our asymptotes. So that we're going to go ahead and calculate. So a squared is 9. So we'll say a squared equal 9 and b squared equal, we'll go ahead and calculate those right here. A squared equal 9 and b squared equal 16. So a is going to equal, so you'll take the square root of both sides, and you're going to get a equals plus or minus 3, and b is going to equal plus or minus 4. So we have 2 equations for asymptotes. So we're just going to take the, we'll take the positive value because we're going to plug them in twice anyway. So we're going to get y equals 4 divided by 3x, and y equals -4 divided by 3x. So we'll come in here and we'll sketch. Starting here, we're going to go up 4. So that's going to give me, so we'll go 1, 2, 3, 1. Oh, that's way more than 4. So 1, 2, 3, 4. And then we're going to go +3. So we're right here. And we're going to go 1, 2, be at +1. Here we go. So up 1, 2, 3, 4, 1, 2, 3. And then for this one, um, oh, it's gotta be plus K, even though they didn't tell us that. Cause that makes me have a y-intercept of, hold on, 1, 2, 3, 4. I'll have to research that. We're just gonna go with it. And then, we've got -4/3. So we're going down from the center. We're going 1, 2, 3, 4. And we're still going positive 1, 2, 3. So we'll be right here. And then we'll go up 1, 2, 3, 4, and then we'll run -3. 1, 2, 3. That's gonna put me at -3. -1, from 2 is -5. So that's so that's going to be at 8, -5. Yeah, 8, -5 right here. So hang on a second. That's this line, and then that's this line. So we'll find one more point. We'll go for this one. We can go down 4 and over -3. 1, 2. So that puts me at -5 right here. Okay, so let's go ahead and see what it looks like. Me sketching a graph on live television that I've never done before, but at least it's not TV, it's just YouTube, but still. All right. I want to use this so I can get pretty close. Wait, that's the graph that I found, so it has to go through all 3 things. And I'm just going to dash it because it doesn't really exist. It has to go through my center. It's an asymptote. It's a partition in our graph that basically the graph approaches this partition, but it doesn't actually appear in the graph if you graph the function, and it just basically affects the behavior of your graph. And it's a perfectly perpendicular intersection through the center, as far as I understand. Now, can I make a mistake? Yes, I can. So I don't know. I hope I didn't, but it is possible. And anytime that you're learning something new and you don't have a lot of practice with it, you run the risk of doing that. So here's our happy little center at -2, +4. And then here are my asymptotes. So I kind of know that the function is going to be existing in here and here. This is probably where the party is at. Okay. So I've got my center and I've got my asymptotes. So now what I want to do is figure out where my vertex, the vertices where is my vertices? So it's going to be plus or minus A. A is 3. Plus or minus, so A is 3. Three. And it's probably going to be right here at 4. My K value, what is K? It's my center of my circle, which is 4. It's positive 4. So we've got K equals positive 4. So we've got vertices at negative, A is 3, comma 4, and positive 3, comma 4. So we've got, let's see. Oh, it's not negative 3. Hang on, it is negative 3. It's here, comma 4. But you're going to subtract. So how would we figure that one out? It's the other vertices is going to be at negative 1. Negative 1, comma 4. I can see it right here. So we've got negative 3, 4, and negative 1, 4. Interesting. I have to pull up the tab and look. Okay, so it's not. So there's probably another formula for if it's not centered at the origin, it's going to be A. It's going to be shifted. So how would I write that? Anyway, I have to figure this one out. Question mark. All right. But I'm not going to let it get me too distracted. So this other value, the directrix, is a vertical line that appears between, so it appears between your center. So it's in here, it's between the center and the vertex. And then the focuses are on the other side. So I think that the order goes center. So here's your center. And then it would go, your directrix would be a value in between here. And then here's your vertices and your focus. So what I want to do is, see, I've already been working on this for 30 minutes. The directrix and the focus, we'll go ahead and calculate real quick, and then I'm going to go ahead and what I found really helpful was taking and finding the graph that was centered at 0, 0, and then shifting it. So this would be your vertical shift, and then this one would be your horizontal shift. So you could, what we're going to have to do, because of this vertex situation, we're going to have to, because the vertex got shifted 2 units. No, that's 4. Negative 1, no, that's only 2. It only got shifted 2 units. I have to figure out why. So what we're gonna do is we're gonna find other points in this graph because I didn't realize that I was gonna run into this issue. But it's the same as the graph x squared over 9 minus y squared over 16 equal 1. And then that would have, so this is putting your a is still equals 3 and b is still equals 4. Only your center here is going to be at 0, 0. So we had to shift down 2 and to the positive, to the right 4 to get to the center. So we're going -2 and up 4 from 0, 0. Because the vertex would be at plus or minus a, which was 3, 0, only we had to shift the graph down 2. So the x value is getting shifted 2. So that would be so it would be 3, 0 minus -3 minus 1 would be -2. So let me try that. -3 minus a minus 1. That's -3 plus 1, which is -2. Okay. Anyway, I'm gonna have to figure that out. But I can go ahead for now and trust that if my center was at 0, 0 and I shifted it -2 units and up 4, that's what I did here. So then if I had vertices that were supposed to be at -3, 0, then I shifted them over 1, 2, and up 4, it would put them here, not there. And then the same one for here, if it was at, no, it was -3, 4, and then positive 3, hang on, 1, 2, 3, and I shifted it over 1, 2, 3. It would be at 3, 0, and I shifted it 1, 2, and then 1, 2, 3, 4. We'll put it here, and that would put it at 1, 4, and then this one would be at -5, 4. All right, so I think I found the vertices of it. Yeah, these graphs are not, they're not fun. So a equals 3 and b equals 4. Let's go ahead and calculate c. It's the square root. It's a squared plus b squared. So it's going to be 9 plus 16. So that is the square root of 25. C is plus or minus 5. So we'll say C equal 5. And then let's see what else we gotta do. What I want to do is I want to take this equation, and since I have a little bit of room down here, I'm going to solve it for y and then plug in some points here so that I can get a table. And I have my center here, I have my vertices here, and I'm suspecting that it's doing this. But what I want to do is I want to find some values right here around my vertices. So I can finish sketching this thing. All right, and this was probably the focus. It says that the focus is at plus or minus C, and C is at plus or minus -5. Okay, goodness. Negative, not. Wait, it said -3 right here, and -1. -5 and +5. Okay, that's not gonna work either. So if this one is at -5, then this one would be at, that's going to be a +3. Okay. All right. Anyway, what I want to do is I want to find out what's going on at -4. And I already know what's going on at -3. I should get a 0 there. If I plug in -3 to that function, it should give me a value of 4. And if I plug in a 1 to that function, it should give me a +4. So maybe we should start there. If I want to solve this thing for y, then I'm going to subtract the quantity x squared divided by 9 from both sides. So that's going to look like this. It'll look like -y squared over 16 equals 1 minus x squared over 9. And then we're going to multiply everything by a -1. And it's going to give me y squared divided by 16 equal -1 plus x squared over 9. And then multiplying everything by 16. Then those are going to cancel, and you're going to be left with y squared equals, and then you switch the order, 16 times x squared over 9 minus 1. And then if you take the square root of both sides, you're going to end up with y equals, and then 16 times this is the square root of 16 times the square root of x squared minus 1 over 9. And then if you add those two numbers together, this is going to be -9 over 9. So you're going to end up with y equals 4 times the square root of x squared minus 9 over the square root of 9. And finally, you'll end up with y equals plus or minus 4/3 times the square root of x squared minus 9. And this is the function that you will enter into your calculator in order to graph the function. Or if you wanted to evaluate it, you can store values for x and evaluate your function. We'll go ahead and do one of them by hand, just so you can see the algebraic method and what your calculator is doing internally. So what I'm going to do is I'm going to erase. So my center, I'm not going to worry about the directrix right now because it's just a vertical line that's used to calculate eccentricity and prove whether it's a hyperbola. So we don't need to worry about that. I'm going to box these and erase some of this. And I'll just rewrite it here. So I have 1 center, 2 the asymptotes. Is that y equals 4/3 x plus or minus 3, the focus, is that plus or minus c. C was I'm gonna put c, 0 because I'm not even sure if that's the actual focus or not. I don't trust it because it's got to be shifted. And then the vertex, I'm not sure about the vertex either, so we're gonna erase that. I rewrote that. Make this a little bit smaller. It says the center is at -2, 4. So that. All right, because I need room. So basically, the process is going to be that I took and I rewrote this. So it's x squared over 9 minus y squared over 16 equal 1. And then I'm going to shift it from 0, 0. So I solved it for y equal plus or minus, right here, just rewriting this, 4/3 times the square root of x squared minus 9. And this is the value that I'm actually going to be evaluating for my table. So I'm going to go ahead and start with, we want to verify the center. So I'm going to start with -5. This is my center. We're going to start with, that was the focus. Let's start with the vertex. I can't believe I didn't put it in here. The vertices. 4. So what did I say it was at -3, 4? And I also thought it was at -1, 4. Let's go ahead and verify that first. So y equals plus or minus 4/3 times the square root. So what we're doing is we're plugging in for -3 for x into this function and evaluating it. So we'll just do the positive 4/3 Square root of 9 minus 9. That's a 0. So -3. So the vertex is at -3, 0. -3, 0. All right. So then, so +3 is also going to be 0. Oh yeah, we have to shift it. That's right. We have to shift it. It's for this one that's at 0, 0. -3, comma 0. And that one was at +3, comma 0. So we're going to shift them. Won't that put my vertex at -5, comma 4? And then this is going to put it at 1, comma 4. All right, so that helps. So there's those two. Let's go ahead and do the next one then. So let's check. We did 3, -3. Let's do -4 now. So let's see, 4 squared is 16. Minus 9. Let's see, let's do 36 minus 9. What was that? That's 25. Okay, let's do -6 now. Y equals 4/3 times the square root of 6, -6 squared minus 9. So that's going to be 4/3 times the square root of 36 minus 9. 4/3 times the square root of 25. 4/3 times 5. What is that? 20 divided by 3. So we've got -6 is 20 divided by 3. However, we have to shift the graph. We've got to shift the graph. So -2 units. So that's going to give me -8. And 4 units up. What is 20 divided by 3? It's saying it's 32 divided by 3. It's shifted up. All right, so -8 is on there. This is not the best way. And it was 32 divided by 3. -5, comma 4. And then we're going to do -4 next. It says it's about 10.6. So -8 and 8, 9, 10. So it's saying -8 is on there. So it looks like what's going on. This kind of thing. So because then -10, -11 right here is also going to be on there. So it looks like this kind of thing is what's going on with my hyperbola. And then should be something similar here. If we went out +6, we would also be here. Wait, that would be 4. 8 from 2. Right here. Okay, so this kind of thing is going on. Yeah, hyperbolas. All right, so yeah, that's almost an hour, and I don't even feel like this was a good, accurate sketch. So uh, grabbing a horizontal parabola, I feel like that we should go ahead and call it good there, because it's I know that I didn't get to get a good accurate sketch of this. I know I didn't, but we've been almost in for an hour, and this has been a very good practice for me. So I don't want to get uh, too carried away with it. I, I think that that's probably a good little volley for the evening, and yeah, so we got to know when to stop sometimes. And what I'm going to do is, this has given me some questions that I need to go and find out, especially about some of these other values that are getting shifted because the shifts in the graph. There's some transformations here. So I need to go back and look at that, and I will. And it's what this is all about anyway, so I will count that as a win. And just want to say that yeah, remind everyone that I will be here Monday through Friday. Right now, it's between 6 and 7 p.m. Central Time, and really here offering this space through this platform, hoping that maybe possibly I could help some students, and we'll just see how it goes. This is new for me. Been doing it for a couple months, and I don't really feel like I'm good at it yet. But again, just a reminder, I am Professor L, and I will be back again tomorrow, and find something relevant maybe to talk about, and get some more time on my board. So if you're needing some help with your math, you want to come hang out with me between 6 and 7 p.m., you're more than welcome to do that. And yeah, again, it's open to the public. So I will go ahead and say goodbye for now, and I will see you next time. Bye.